All right. Well, welcome to the Overview Podcast. My name is Tag Durant. I am a PhD student here at Stanford University and a member of the Overview, joined by
Isaac Ward.
And today we have two very special guests on our podcast. We have Evan Kay and Cameron Flannery. Why don't you guys take a second, introduce us, tell us who you are.
Definitely. Thank you both for having us here. We're really looking forward to the conversation. My name is Evan. I'm the co-founder and COO of Navier AI.
And I'm Cameron, the co-founder and CEO of Navier AI. So thank you for having us.
Yeah, it's a pleasure. I think we want to dive right into it. We are very excited to have you guys here because I feel like there's a ton of entrepreneurial spirit, not just here at Stanford, but with aerospace students across the country because there's so many cool aerospace-related startups going on right now. But before we get into that, we want to hear a little about your guys' backstory and where you guys are now co-founders of a Y Combinator-backed startup. You guys are doing amazing things. We want to hear a little bit about just where did you go to school and what was your career path that led you to this moment here?
Yeah, well, we went to school together at UCSD. That's where we actually met. We were in a club together that we co-founded called RPL, the Rocket Propulsion Laboratory, with the intention of building and launching some small liquid propellant rocket engines.
Is that completely student built?
Entirely student built. Nice. And student success rates with that, I would say.
Mm-hmm.
So it was a lot of fun, but we used that to get a lot of experience, both building an organization and building hardware, building things. And I think since then we've wanted to start a company together. So for the past 7 years, we've kind of been cultivating the right experience and the right level of expertise in various domains to feel confident to go out and do this.
Yeah, I think when we were at UCSD, there were a couple of other rocketry orgs out there, but I think there was something missing that I think both of us really wanted to go pursue, just in terms of a unique environment, very fast-paced, and just kind of having our own org to really drive things forward for a unique competition. And so that was a really great kind of starting point of working together in college, and then post-college through all of our internships and kind of early career opportunities, really targeted the different types of opportunities we had to help us or position us into starting a company.
Cool. I mean, our audience is super interested about internships. That comes up a lot.
Yes, they are.
Do you mind mentioning any specific experiences or things that, sort of spoke to you? And
Yeah.
You can start off.
Yeah, go for it. I think in terms of my career path, I definitely took more of a hardware-focused kind of background.
Mm-hmm.
So I kind of stumbled my way into metal 3D printing. So the student org that we were part of actually 3D printed a rocket engine, but I had stumbled my way into working at an early stage startup doing metal 3D printing on campus.
From the campus of UC
Yeah, UC San Diego. There's a couple of older students who wanted to try to start a company to metal 3D print rocket engines, which is definitely a super exciting and interesting opportunity.
Is that kind of similar to like what Relativity Space is doing? Because I know they're doing a lot of additive manufacturing, right? Is that kind of a similar vein as those guys, or how is that different?
Yeah, just at a much smaller scale, I would say.
Yeah. I think not the entire rocket.
Like. Just focus on the engines.
Yeah, just the engines. I think SpaceX really pioneered metal 3D printing for rocket engine components, almost 15 years ago now at this point. So a lot of people kind of saw that and started to bring it into the student orgs as a great application or use case for 3D printing. So everyone wanted to try it kind of at the smaller scale. I stumbled my way into it on campus and then ultimately did an internship at JPL doing metal 3D printing for Mars 2020 components.
Nice.
Less so for rocket engines, but just smaller heat exchangers and whatnot. And then ultimately ended up at SpaceX doing metal 3D printing as well, before jumping over to a unique opportunity to do venture capital, and then started the company with Cameron. And Cameron had, I think, similar unique approach, just more software focused.
Yeah, I think internships are probably the most important thing you can do as a college student. It's, I would say the second most important is getting the club experience, and that is really what gets you those internships. Sometimes lab experience is pretty helpful in that as well, but I think it is really extracurriculars, clubs, hobbies, things that you have on your GitHub, personal projects. My first internship experience was the last quarter of my sophomore year. Over the summer between freshman and sophomore year, I did nothing particularly interesting or exciting. I just kind of worked random jobs doing lighting design for some stage productions.
Mm-hmm.
But I saw some of my friends and colleagues in aerospace getting internships at cool companies, and I realized that damn, I'm missing out. I'm not doing something right here. So
I think we've all felt that at some point. The aerospace FOMO, when oh, he's off at NASA, he's off at SpaceX. What am I doing this summer?
Yeah, and then I went to my counselor, and I think she said, don't worry, freshman year is easy. Sophomore year is when you're going to want to kill yourself. And that makes me feel a lot better about this. So then I went into sophomore year with the explicit objective of getting an internship by the summer,
Mm-hmm.
and really more explicitly, and I think to myself, the objective was get an internship at SpaceX. So I think that quarter I joined 2 labs working on various aerospace and 1 astrophysics, and then joined 3 clubs and had no time for anything else in life. But it worked, and by the end of that quarter, I had an offer from SpaceX for the spring quarter of this internship with them at the radiation effects departments in Hawthorne. That was more of a software/hardware role. It was doing radiation effects testing for electronic components. After that, I stayed at SpaceX for about 9 months and then got another internship. I think my next one was Tesla, and
Also
then
a solid
SpaceX
company.
again. Yeah, the internship experiences are by far the most important thing you can do in your career as a college student. I think that is really what sets you up for success later in life. And I think, we look for students, for new grads in particular, who have internship experience. That's really one of the top things that we look for on resumes.
You said when you're hiring
When
at
we're hiring
Navier AI,
for full-time,
you're not looking at who's got the 4.0.
No,
You're
it's-
looking at what have you done outside of class.
Yeah, honestly, I can't even remember the last time I really looked at a GPA.
Really? If a GPA was like 2.0 on a resume, would you just skim past that, or are you looking for?
Maybe this is a bad thing for me to say, but if somebody didn't put the GPA on the resume, I honestly wouldn't care. Like it's
Wow. Okay.
Yeah.
Okay.
Did you have some cool experience? You have some cool projects? Can you tell me about them? Can I see your GitHub? Like that's
Yeah, straight to the GitHub link for me and see some of the personal stuff that
Yeah.
they've done, which is
Nice.
super exciting to me. But yeah, that's what I always keep an eye on.
That's a good point for students because I've been asked by a couple people like, oh, like, when you went to Stanford, you applied for this, like, what was your GPA when you applied?
Mhm.
And I'm like, oh, I had this GPA, that GPA. And like, okay, mine was kind of low, so I guess I won't be able to do that. And I try and say, no, like your GPA, sometimes you have to check the box for certain minimum requirements. But beyond that, I feel like the more ways I stood out have been, I had this experience and I connected with this person. I have this network, right? And most of the time, most of the cool opportunities I've gotten had nothing to do with my GPA. Like people never ask me about it.
Yeah.
I don't think I've ever once been asked like, what was your GPA? I'm sure they
Like
check it when you do like a first like, okay, maybe not. Maybe that's the secret.
I think as soon as you get out of academia, as you guys are saying, like it really just becomes less of a talking point. You really just want to know what people can do and do on their own motivation, right?
Exactly. And I think a GPA tells us a lot less than a project does.
Totally. I'm interested. I mean, it's obviously a ton of space sort of heritage experience. You mentioned VC as well. So I can sort of see how it all comes together, but could you connect the dots a bit more towards Navier AI? I mean, you guys obviously came out with a lot of experience. And then, what made you want to take the plunge? How did the idea come together? I mean, how did you guys, first stumble upon this idea together?
Yeah, I think so the first time we talked about this was 2020. It was in the middle of the pandemic. I was working at a company called Boundary Technologies, which is a startup doing hydrofoils in the Bay Area.
Mhm.
I had spent maybe the past 4 months of my life just like fighting ANSYS and trying to do simulations that had cavitation and like the free surface effects. So, but a bunch of different phases, bunch of different fluids, really complicated geometry with motion, and like rotating meshes and all this weird esoteric stuff that ANSYS doesn't do very well. And I was pretty fed up with that, and had taken like 3 months to get to a thing that was like okay, that I definitely knew was not optimal. So that was really a turning point in my perspective on simulations. And then after that company, I went to Aurora Innovation, which is a self-driving car company in the Bay Area, and they're using simulations, as are a lot of other companies in self-driving. Waymo actually published some stats saying that I think have driven over 20, is it something ridiculously large, like 20 billion miles in simulations. And they use these simulations for both testing and for developing new models, to continue to train the models on weird scenarios. I think the thing that really struck me as being really interesting and really potentially valuable about that is the fact that these engineers that are creating the simulations, in a lot of cases, aren't the PhDs in numerical methods. In a lot of cases, they aren't actually engineers. They're just operators that have experience in cars and know what scenario to create. So if you can create a very complicated simulation for autonomous driving and run that very quickly and use that to develop this software 2.0 for the car, I think the same thing is going to be true for developing hardware. Much faster, easier simulations should allow us to develop hardware 2.0 that's more learned and more generatively designed based on these simulations that are driving the design based on physics.
Super cool. I mean, I guess you're speaking a bit about speed of iteration there, and when we read through some of the material on your guys' website, it's obvious that like speed is a really big part of it. I wonder if you can give kind of a layman's explanation as to why CFD stuff is so expensive, why it can be so slow, and what are the opportunities for speeding it up to the kind of magnitudes that you guys are talking about.
I think it's not a huge secret. I mean, feel free to jump in. It's
Yeah.
not a huge secret that CFD solvers are just slow. Like,
That was not
Yeah.
that's half my PhD is CFD is slow, make it go faster.
So I think everybody knows that the solver is slow. The solver is slow for many known reasons, and there's a lot of people working on trying to improve that. There's also a part of it that's kind of less discussed, but just an inherent part of it, which is the entire workflow for creating the mesh from your geometry, cleaning it up, sending it back to your engineer because it had non-manifold faces, and then remeshing it, and then finally going through the process and realizing your mesh wasn't good enough, and then iterating again and again, and then finally getting a mesh that's right, and then you go to test, and then it doesn't validate against your tests, and it's just a mess. Like, it's not a process anybody really wants to go through. The I guess, yeah, the main reason why simulations are not used more today is this lengthy process. And I think the solver is one big part of that. And that's really what we're focusing on and what we use as our metric of our speed improvement. The other part that's a little bit less easy to measure and more, I guess, just process based is really the CAD file to the point at which you're ready to run the simulation. And that's something that we're also just drastically simplifying with the methodologies that we're taking, but it's hard to put a number on that.
I can relate to that a lot. It's like I have spent so much time. Like it just seems like it should be so easy, right? You're like, I want to know what is the lift on this aircraft, right? And it's like, okay, well, first I know this is the geometry. Now I got to make a mesh for the surface geometry, right? And I got to create the CFD mesh, and that mesh, doesn't have the boundary layer, right? So I got like manually took out the boundary layer, right? And it seems like everyone I talk to in my lab, they're like, oh yeah, the mesh generation is like so hard. Right. Yeah. And then even if once you get past it, then you also have the solver. And if the solver then takes 3 days to run, you can't do an optimization doing like thousands of points. If every time you do 1 point, it takes 3 days, right? No one has 3,000 days to get to an optimal design, right?
I think we really want to build a product that looks like what you'd expect a simulation product to look like if you had never run CFD before.
That's a good way to put it. Yeah, because sometimes you use these tools and you're like, this is CFD? Like, shouldn't this be cool? Shouldn't this like look fun? Like,
should be excited to run CFD. Right?
Exactly. What about you? Did you have any like CFD experience, ML experience before this, or like what led you to want to join in this idea?
Yeah, I think what's interesting is going through the metal 3D printing path. Topology optimization or generative design is huge across all the industry, right? So with metal 3D printing, you end up with essentially design freedom, or really being able to design performance into parts. I think a lot of the different types of softwares and applications are super interesting for that, because you can really inch out a lot of performance for most 3D printed parts if you design them well. So like rocket engines can have internal cooling channels to really optimize the performance and keep it at the ideal temperature for your specific operating conditions. So I think I've seen that across a number of different types of applications, but what I think the main challenge is not everything should be 3D printed, and there's definitely a gap in terms of different methodology around what types of parts should be 3D printed and how people can apply different design methodologies into more standard or more incumbent manufacturing processes. And so after talking through a lot of the types of headaches with simulations with Cameron, I think it was very obvious that speeding up simulations are definitely absolutely necessary to really drive or really create physics-driven design for all types of designs across the hardware space. So taking a step back and not only looking at metal 3D printed or additively manufactured parts, really using simulation to drive all design across the board and picking the right processes to do it.
I like that. Because I'm a big believer in simulations, obviously because I'm doing my PhD in computer simulations. And I think it would be so helpful to have like faster simulation tools. But some of the things that like make me a little bit skeptical when you talk about like doing machine learning and AI, these buzzwords, right? There's so many startups that are like, we're doing AI this, AI that. Sometimes when I think about like CFD simulations with AI, I'm like, are these gonna be accurate and trustable? Because sometimes we have these complex simulations where I'm like, there's a very specific problem, like that's very niche, like, is your guys' solver going to be capable of solving like all sorts of problems? Is it for more like a base guess on like your just general lift, or what do you see as the limitations of your solver?
Yeah, I guess there's a few answers to that. So we definitely need it to be trustable for it to be used by engineers. That's just the base level requirement. And I think that's one of the things that's unique about deep tech startups. There's a much higher threshold before you can get to an MVP. YC has, they generally like companies to launch quickly and to get to customers as fast as they can, even if it's a shitty prototype that you built in a weekend. That doesn't really work when you're doing physics. You can't have shitty physics and have a usable product. So the threshold's a lot higher, the bar is a lot higher. We have to build that trust, and we have to show that we can perform simulations well on a lot of verifiable cases. The difference between a CFD solver traditionally and an ML solver is another interesting one too. I definitely don't expect or really want our solver to completely replace traditional solvers. In fact, traditional solvers are kind of required for us to exist. That's how we get our training data. We build a huge amount of data based on traditional simulations. But I think one of the things that we've learned is that, I guess I can say a lot about, you need high quality data in, and then you'll get high quality outputs. That's a big part of ML. But the other interesting thing is, when do you even trust in a CFD simulation itself? Most CFD simulations aren't. So
you can spend 7 days on it and still be completely wrong.
Yeah. I think trust is key, and I think CFD simulations, traditional numerical methods, are hard to trust anyway. I think we're going to have to go through maybe a few more steps to prove that we are trustworthy and that our simulations can provide engineering insights. But I see it as the same challenge of new solvers that are, be it GPU accelerated or LBM, whatever it may be. There's a trust threshold, and there's methodologies that have to be taken in setting up a simulation to get to a point that you can say that this simulation is an accurate representation of my actual physics.
Absolutely.
Okay, so it's not really meant to be a super generalized perfect solver in every sense. It's really meant to...
Don't know if that exists.
Yeah, I guess you're probably right. Yeah, so can you talk a little bit about, getting into the nitty gritty of it on the AI side, ML side? We hear about big models like ChatGPT and, all sorts of stuff, and data hungriness is something that gets talked about a ton. I know CFD data can just be absolutely huge.
Yes.
Can you give us an insight into the scale of data that you guys deal with or are likely to deal with in the future? It sounds like it could be massive.
Yes.
Very much so. I think I won't give out specific numbers, but I think, as I'm sure you've all seen in just generic CFD simulations, if you're looking at, call it a simple kind of steady state case for an automotive vehicle, of course, you'd expect single cases to be on the order of terabytes, right? Especially if you want high fidelity data. There's a number of different ways you can compress it or manage it or downsample it, et cetera, et cetera. But when you think about just the generic cases that people are using today, the order or the magnitude of scale just for CFD data is terabytes, and obviously that will scale very quickly to the petabyte size of things, which is a fun, challenging data problem, but definitely absolutely necessary to get that high fidelity data that you need.
Yeah. And tying that back, you talked a bit about Y Combinator and how for deep tech there's this additional challenge. As you say, you can't just sort of slap something together on a weekend when you're dealing with stuff of this nature. Can you speak a little bit about how that experience has been? I know a lot of Y Combinator stuff is maybe not as involved as what you're looking at. How do you guys fit in the cohort? Have you found yourself having to explain actually what we're doing is a little bit different or anything like that?
Yeah, I think so. I think the average company definitely, and I see it in 2024, at least 2023, the average company is building something based on LLMs. And there's a lot of really interesting, really exciting applications being built on top of LLMs. So I think not necessarily with YC, I think they're pretty knowledgeable about what we're building, but we've had to communicate in general to people in the investment community that ML for CFD is not an LLM or not built on top of ChatGPT. And I think that's one communication thing that's been a little bit frustrating. I think it just, it's like an additional layer of explanation that is required. But I think YC has, they have a lot of good general advice. I don't think they really intend it to be very specific. I think they intend for companies to take the general advice and to, listen to what they, filter what they know is not relevant to them. And that's something that I think we had to build up over time. So we had maybe too loose of a filter initially, and then eventually got to a point where we understood that, okay, saying that we should go and find a customer and get them to try this terrible version of our product now is not really meant for us. That's meant for somebody else. Understanding what to listen to and what not to, I guess, is the point.
Yeah, I think that actually applies for just all advice from anyone, to be completely honest. It's always helpful to just take a step back and understand how that advice applies to your specific scenario. A great example is you should be talking to customers no matter what. So regardless of pre-product or post-product, understanding how a user would use your product is extremely important. So very valuable advice. How we apply it in our specific scenario obviously is going to be different being pre-product at the time. So it's all just interpreting it to your specific scenario.
And the audience can choose whether or not to listen to advice on this.
Yeah.
All advice given here. You choose, you filter it out, right?
Yep.
Well, let's get into a little bit more of what it's like to be a startup founder, because that's something I'm super interested in, and I think a lot of our listeners are too. First off, is it more or less busy and crazy than being an engineering student in college?
You're talking about this on the way down here. Uh, I think it's hard to match the energy of a college student who's excited to join, 2 different labs and 3 different clubs and
Oh yeah.
start a new club and get an internship. But I think we're busy in different ways. I think we're busy with higher stakes, I would say. There's kind of a latent stress, and actually the way that I put this to Evan and to my wife is that I feel, sometimes stressed, pretty frequently stressed about work and stressed about what we're building. And then if I take a break, I feel stressed about the fact that I'm not working. It's just this kind of perpetual cycle.
Yeah, I'd say college felt busy just running to different clubs, going to different meetings, going to class, doing homework, studying, going on trips, etc. So it felt busy, but it was more like fun, social busy, I would say.
Yeah.
Definitely when you move more towards the startup life, you're really focusing on building something that we're at least very much are very passionate about. And so I'd say from the stakes perspective, it's way higher than it was in college. But I also would say it's significantly more rewarding. So it's a nice balance.
That's good because I mean, I guess it took a lot of faith to take that leap from like a normal, more secure job to like we're going to start a company, right? Because that's just obviously not that's not like 100% guarantee you're going to succeed, right?
Yeah.
Obviously, you hope you believe in yourself, right? But what was that leap of faith like to leave behind? You guys obviously could have worked at some very prestigious companies. What gave you that faith to take a step into a risk and start a company?
I would love to hear your answer as well. But I guess jumping back to YC, I think this is one of I think YC has 2 very special parts of our company. One is getting us off the ground, and 2 is really helping us with our fundraising. So initially, we had been talking about this for a while, and we had kind of started doing some light prototyping, and then decided to apply for this early AI admit for the Winter 24 batch, which was, I think we applied in July, and then got in end of July as well. But it effectively was like I sent Evan a text on a weekend on like a Sunday, and it was like, "Hey, there's a YC application due on Tuesday. Should we just do this?" And we
you guys had probably discussed the idea some before that, right? Like how
we talked about it. We talked about it in 2020, and then we been like we should probably pick this up again. Like we should start a company at some point. And then that came up, and I was like, might as well. So we created a very quick application, applied, and YC's process is pretty easy and I guess not easy, but pretty smooth, I would say. So by Friday, we had our interview with Jared Friedman, our investor there, and then had heard back from them on Saturday morning, I believe.
Yeah, it was like a 6-day process.
That's crazy. Less than 1 week, and you go from like not sure to do this to now you're like you're getting backed by some legit investors.
And I think getting backed by YC is definitely one of the things that made us really confident to go out and leave our comfortable, pretty exciting jobs. Honestly, I was pretty happy at Aurora to go do something that I feel I have 0 regrets. I feel like this is still the best job in the world, and I don't think I'd ever want to go back to anything else. So it definitely is very helpful having that confidence from, I can have as many ideas as I want about different startups and feel extremely excited about them, but having an investor and having somebody else come, including a co-founder, come and say that, yes, we all believe in this and we think we should pursue this, is a very big part of like what pushed me to take the leap here.
Yeah, I think from my perspective, like Cameron had mentioned, we spoke about starting something at some point for so long that it felt like a matter of time, and we both really wanted to start a company at some point, and so very intentful in regards to the career path we were taking. And so once the opportunity popped up, there was no questions of, okay, let's just throw something together and like shoot our shot, right?
Yeah.
And everything worked out in our favor. And so
the shot hit and you're ready to go.
Yeah, exactly. And so once we got the offer to join, or the offer to be a part of Y Combinator at the end of that week, there was no question of, oh, do we do it? It was a full like, yes, full send it. Like we're going to do everything we can. We're going to make it happen. And so it felt like a lot of preparation up to that point. But
then you guys were both together. Like we're both all in. Was it pretty switch as soon as you knew your Y Combinator backed? Was it both of you just any hesitation after that point?
Not really. I think I took like a bit of time to ramp down out of respect and for both my
you can't just walk out.
I had yeah, I mean, I don't know. Looking back, I feel like it was the right choice to do still, but I would give a lot for another month of time to work on this.
Yeah, definitely. But I mean, like literally right when we got in, it was like hop on a call right after we got off the call with YC. It was like, so we're doing this, and we were super excited. And like literally later that day, we're like, all right, how do we incorporate the company?
Wow.
Get all our ducks in the row and make it happen. And then, of course, we wish could have just kind of gone heads down 25/8 sooner, as you always want to, but ramp things down over the next few months to really do this.
Many different things that can be pursued. You guys are talking about how you obviously are focusing on like ML-based accelerated flow. But yeah, the funneling process, I think it's like a problem that maybe engineers specifically have an issue with, just because, as you say, there's just so many cool things to do, and you guys already had this big breadth of experience in a ton of different fields, so you probably were exposed to a lot of cool problems. Why this cool problem?
There are a lot of cool problems, and there's honestly so many more cool things out there that I think at some point we'd also love to work on. But we did go through that process. I think some of the more crazy ideas that we discussed were space-based solar power for aircraft. So if you want a transatlantic aircraft, how do you have enough power without making the batteries ridiculously heavy? Well, just beam power to it from space. I'm glad we didn't do that one.
I was gonna say there's another Stanford alumni doing something with space-based solar power, right?
Right, the gentleman from Robin Hood, right?
Yes.
Yeah.
So I mean, that's something that's another cool problem. I guess that's actually being actively worked on. That's
I guess the overarching theme though is like we would have done something space, but I think we had a passion for this specific problem. I think this is something that we both encountered, and honestly, this is a product that we want to build this product so that the next hardware company that we build can use this and really accelerate our design process. That's a really big motivation for us. There's another question on the YC application. One of the questions I think is, if you get in, what are your backup options, or what are your backup ideas? What else would you be working on? I don't know exactly how they phrase that, but it's basically like beyond this idea, what else do you want to work on? And I think in that we also put mining the lunar regolith to make really big antenna or structures in space.
That was that was an exciting one, because we were looking at using just lunar rock to build like massive satellite dishes, and you can actually go buy simulated like lunar regolith off the internet. And so like we were literally shopping for like moon rock just to start prototyping for fun. But yeah, I think we explored a number of different ideas just purely out of interest and like fun. But this is something we kept coming back to as a fundamental piece to build the next hardware company, right? So, I mean, we love hardware, we love space, but how do you really differentiate yourself in that space? Great talent, great engineers, great software. So we fundamentally believe this is the tool that we would ourselves use to build a great hardware company.
So you guys are already looking one step ahead. You're like, this is our tool for like hardware companies. Potentially you guys would start next, or like, would you add that to this company, or would that be after this company, or?
Good question.
I think it's
I'll leave your trade secrets to you then.
Really interesting. I mean, you mentioned, beaming energy from space.
Yes.
And you just quickly added on at the end. I'm really glad we didn't do that. More specific.
You can basically use infrared or microwave energy from space. Those are the two ideas that have been pursued and have some academic history. I think the microwave approach requires antenna that are just way too big to put on an aircraft. I mean, I don't even want to hypothesize, but I don't think that would work. I think for a lot of reasons, you probably wouldn't want to be in an aircraft that was being by microwaves.
That's a hard sell to customers. Fly in a plane powered by space microwave.
A long time of certification, validation.
And the aerospace industry is notoriously fast at proving
of course.
things like that, right? I think the other option was infrared, and that's a little bit more feasible. You still need a lot of power, and it just wasn't practical for the size of the vehicle. And I think we basically would have been like cooking the vehicle. Would have
minor problem.
A bit hot in there.
Super funny. I think just one more thing, sort of on the again, our audience is very engineering, and in engineers, like, we care about sort of doing cool problems. There's these problems that are close to the heart. I mean, even when you guys are talking about some of these backup options. There's the glint in the eye. I mean, we all have these sort of crazy ideas, big space ideas that we're interested in sort of dealing with. But ultimately, you need to do something that's actually feasible, and you need to do something that has a customer and that you can get investment for. I mean, there's practical considerations on the business side of this equation. So do you guys struggle with that at all? I mean, it seems like you narrowed in on something that's really feasible, and obviously you're getting back from YC. Any advice, I guess, to students, engineering students in particular, who are kind of looking at these cool problems that maybe are a little bit more, far from commercialization?
This is actually one of the areas where I think YC's advice is pretty good, and it resonates with almost every company that I can think of. It's basically pick a beachhead market, pick a specific customer that you want to solve a problem for, and solve their problem really, really well. From there, you can expand, but we're not going to try to boil the ocean, and we're not going to solve aerodynamics and CFD simulations for every single application out there. We're going to solve a problem for a very specific set of users, make them really happy with this product, and then expand from there. And I think that's really just good startup advice all around.
Yeah, the only thing I would add there is if there's uncertainty in regards to if there will be a paying customer, where it's maybe a great idea, but you just don't know if anyone wants it, I'd strongly encourage to reach out to anyone in industry who might be a customer and just understand what their actual problems are. It's always helpful to just have those conversations, and maybe they explain a problem that really is you're passionate about and you really want to work on. And so you inherently just get the inverse of now you have a customer, you know what their problem is, and now you build to that. And a lot of the times, especially if you're kind of earlier in your career or in college still, people in industry are willing to have the 30-minute conversation. Because I think throughout my career, I've reached out to a number of different people and gotten the slight mentorship. And so I think people are always willing to pass it on.
Yeah, and you really should be your own customer. Like you shouldn't start a company for products that you would never have used or never had used the thing you're replacing or would have used in industry. It really should be you should be your first target audience, in my view. I think that's really how you get the best products.
Yeah.
Cool. So yeah, be your own audience, I guess.
Yeah.
Identify that beachhead market really early on and reach out, I suppose, often and a lot.
Mm-hmm.
And in the reaching out process, I mean, are you just talking cold emailing, just finding people online who might have the expertise or within your own network?
I would definitely say, I mean, I think this comes with the commentary at the start of the conversation around internships being extremely valuable. Being on site with a bunch of great engineers at really any company, just having those conversations over lunch is super awesome. Throughout internship experience, you end up gaining that network such that you can just reach out to some of the engineers you cross paths with or worked with to ask these questions, or friends of friends, right? And so I think everyone in college is always struggling through it together, trying to lift each other up as you all move into industry. And so trying to leverage network as much as possible is definitely the right way to approach it. Cold outbounds are definitely okay as well, but I think that the success rate is definitely lower.
Yeah, I think you're definitely a lot better at that than I am.
The cold emailing?
Yeah.
You just gotta get them with that first one line and something extremely compelling, focused on their specific background and
Please
problem.
don't make it a ChatGPT.
And then, you will not get a reply if you ChatGPT anyone outbound or ChatGPT inbound us. We will just auto ignore.
We'll take a picture of it and put it on a Slack group that we have, making fun of these bad apps.
I heard a funny one recently. A mate of mine was like, on my first email to someone, I just put in, hey, just following up. I tried to reach you, but what's the next steps? As though they had already been speaking. I thought that's such a...
Did it work?
Yes.
Oh, okay. Well, that's a little maybe borderline on the moral area there, but I mean, whatever gets in the door, I guess, right?
Yeah.
Well, for you guys, as you started this company, you've been doing it for how long now?
A little bit over a year.
A little over a year. What so far have you seen any like big mistakes or things you wish you would have done differently that you would pass on a lesson for someone who's going to go through the same process? Has there been any, or you guys have you been perfect so far? Like what mistakes have you made that you would maybe wish you'd learned that lesson earlier that you could pass on?
You want
I
to
can
take
be
it?
specific about some technical things. I think we relied too much on some tech stack that was complicated and had a lot of components that we thought we could piece together to make this work well. And after several months of trying that, we just decided, let's just like go with what our gut told us initially, which is just vertically build this, like vertical integration in this. I think that, I don't know if that's generalizable, honestly. And I think that's honestly a very expensive mentality if you're starting an aerospace hardware company in particular.
But I think the core lesson you said, trust your gut, right? You say your gut at first wanted to go vertical, but then you decided not to go that way. So I guess the lesson could be trust your gut, right? Do what you feel is right.
Yeah. And then I think another thing that I think we've been fairly good about over the course of the year, but something that we've definitely honed recently is just making decisions quickly. At most, I think we spend 30 minutes on even fairly big decisions, then move forward, execute. And if it doesn't work, we go back and redo it a different way and change course. But it's just so much faster to just always be executing, trying things out, learning from failure, rather than spending a week or a month making a doc, theorizing about why this thing is going to work, and then deciding and finding out.
Like academia or something like that, right? It seems like the academic life sometimes. Oh, it didn't work. Ooh, but why did it not work? Like, let's spend a few months figuring out why this didn't work. That's where it seems different in startup life, right? Like, broke. All right, whatever. It's pushed away. Let's go something else.
Yeah, I think time is the most valuable thing for us, especially as an early stage company. And so trying to figure out how we can best leverage it to learn as much as we can, fail and learn from our failures, and really just move forward.
The quick decisions point is super interesting. I mean, good advice all around. But for that one in particular, do you guys, is it just because you have a joint rapport and have known each other for ages, you can make quick decisions, or is there a specific framework? I mean, yeah, any advice on that?
I think part of it is that we've known each other for a while. It takes trust to allow your colleagues to make quick decisions. I think you know the framework idea is interesting. I actually think frameworks. I don't think there's any framework that isn't going to add some latency to that process, some bureaucracy to it. So I really think it's just getting used to each other, getting used to the team. Um, and as we bring on more people on the team, we're going to have to do that learning process with them as well. But it really is just getting to a point where you can, you know the person that's closest to the problem is going to solve it because they care about the outcome and they care about the product holistically as well.
Yeah, I'd say trust and lack of ego are the the
that's
two
good.
biggest things,
Yeah.
right? And so obviously we split up work across the company. Everyone kind of has the thing that they specialize in or are close to, and so everyone has to trust each other to just know how to make the right decision based on their knowledge base, right? And obviously just having a uh, I guess small ego such that you can trust that they're going to make the right decision even if you fundamentally disagree. Just given their experience, right?
I was going to ask what makes a good startup employee, but this advice kind of applies probably not just to the founders, but to your whole team, right? Like, so I guess you would say someone you'd want at a startup would be someone who's trustworthy, they can communicate with you, you don't have to set up all these processes and double check everything they do. Anything else that would make a good startup employee that want someone who would want to come join a company like yours?
We can find very technically talented people that have no interest in the product, and they would not be good startup employees. I think those are some of the best people at larger companies. They have a lot of domain expertise for the specific area of research, but not being interested in the outcome, the overall outcome of the product, and the overall outcome of the company effectively is just a non-starter for us.
So passion and being bought into the mission,
Yeah.
then it's just as important as being technically sound.
Yeah, and in fact, the majority of my intro calls with candidates are about their interest in this product, their interest in the physical domain. I think a lot of software engineers don't have much experience with physical matter. So having some experience in fluid mechanics is great, in aerodynamics is even better. But just having some understanding and some interest in this is really the main thing that I look for in those calls.
Yeah, and given the stage that we're at, where you're still a single-digit number employee, every single person contributes to the culture massively. And getting culture right from the beginning is definitely something that could make or break a company. And so having a group of people who are super passionate about the problem, want to talk about the problem every day, wake up to solve the problem, and just drives them insane, definitely builds the right culture, at least the culture that we're really trying to foster.
Yep.
And in assembling that team, I mean, as you say, you're small, so finding these initial people, where are they coming from generally? Are they from your network, or what's the avenue to get in?
Initially from our network, and I think that's going to be true for most startup founders. Your first few employees will likely come from your network plus two, maybe. So friends of friends. Something that I think we didn't, maybe going back to the things that we didn't do well. I think I didn't spend enough time going out and having like coffee chats with people that I thought were really good engineers at some of my former companies, and not asking them to come work for us, but asking them to tell us who they thought were really good engineers that we should go pursue.
So you wish you would have asked them specifically rather than who do you know? More like, do you specifically want to come work? Is that what you're saying?
No, sorry, the other way around. So
the other way around. Okay.
These people that I thought were excellent engineers, if they had any recommendations of people in their network who were looking for work, who would be interested in this kind of thing, I think we should have spent more time doing that.
People call them super nodes. So it's like the one engineer who just knows a bunch of other great talent, right?
Yeah, exactly.
We know some super nodes.
Yeah, I think it's
cool. What about for students who are looking to go into a startup company, say like students here at Stanford pursuing undergrad or master's or any other colleges anywhere? How should students approach their education? Like what role should school play in their lives if they know they want to go to a startup company? Like should they care about it? Should they just use it to build their network? How should they approach it?
I guess my perspective is going to be a little different, just having only done undergrad with the intent of always going into industry.
Yeah.
So getting a master's or PhD for me was never really a consideration. So I definitely spent more of it as learning the fundamentals, of course, through all my classes, but really using it as a place to grow a network, meet new people, and get hands-on experience across the board. So of course, internships are great, but I think the other nice part about a lot of universities is there are so many different clubs to go try different things and just actually get that experience, as well as labs. And so getting that real world experience is massive, whether it's on campus, in clubs, or in internships, and also just talking to everyone that you possibly can. Because inherently, I mean, a lot of the students here listening to this are at great schools. And so very much so post-grad, post-PhD, your colleagues are going to be at some amazing companies, and so will you. And so network's huge.
Yeah, I think there's a bunch of ways to make your academic career really valuable for joining a startup or for starting your own company. I think my particular take on that is that the ability to apply what you're learning in classes to a company, to a project, to a club is really the key. So internships, clubs, and labs, I think slightly to a lesser degree, but really applying the knowledge that you're gaining in these classes to a real project.
Kind of back to the conversation we had at the start, less about GPA, more about get out there and do something with it.
Yeah, and I think I would also add to that, working in a team is another really big one. I think that's something that's a little hard to really cultivate in academics. You work in small
I want to ask about
projects,
that because I feel like sometimes when I want to put teamwork or leadership on a resume for an engineering job, I'm not sure what's relevant, like what's like useful. Are you guys talking about like clubs, or what teamwork do you guys like to see on a resume when you're hiring?
For new grads in particular, I think the only thing that really would stand out to me is the club experience.
Okay,
Working
clubs.
on the project, and actually like saying this is where we started. This is when we went to this competition in Michigan for FSE or something like that. And here's how it went. Here are the disagreements we had along the way. Here's how we worked through those. Having that experience is really valuable.
Yeah, I would definitely agree with that. And I think we've seen it as early as like first robotics in high school. I think a lot of people get their first team experience through there. That'll carry on to clubs in college, and you can see them go from a team member maybe at the first year of college to leading sub teams at like a rocketry org by the end of their college careers. And so seeing that, I think, is fantastic. I think it's a little tough to put directly on a resume, but being able to speak to it and just understand the nuances of team disagreements or how you make kind of leading decisions and kind of get the team behind you as you kind of go pursue them is absolutely impressive.
Got it. Cool. Well, going back a bit, you mentioned how, when you're finding new people, you're really looking for that like spark, that interest. And sometimes you can have really talented technical engineers, maybe a bigger company or something that kind of have all the smarts and the know-how, but there's maybe not so much that passion and how that's maybe not a good fit, especially for a small company. Do you think that is the key separating difference between the people in a small company and a big company? And what is your guys' experience and the differences between working for a bigger company and now working at Navier?
Ooh, I don't know if I could say for sure is the biggest difference. I think, curiosity, I think is effectively what we're talking about. I think that is definitely one of the main things that makes people leave big companies. Being curious about other parts of the company, being curious about other things, and it's just hard to really do too much more than your specific role at large companies. Yeah, I don't know. What else do you think?
I think the big delta is if you just compare someone working at a startup versus someone working at a large company, like ownership of what you're working on is significantly different, I would say. And I think another thing that's coupled with that is a lot of people leave big companies just from the bureaucracy and like speed of iteration. And so what's nice about a startup, or at least what I genuinely enjoy, is you're really going to own something end to end, and you're the only person that can really be blamed if it doesn't come to fruition. And I think that's just a super unique opportunity that you don't necessarily get unless you're leading massive teams at a large scale company. And so that also puts you in a position to learn at a much quicker rate than you would at, say, a larger company as well.
Yeah, I think maybe I'll add one other thing to that. I actually don't know if the distinction between big and small is really the right one here, because SpaceX is a pretty big company now and they operate with this sort of mentality. I think it is ownership, and that can exist at big companies. And additionally, just a lack of the political infighting that happens at big companies. So, at Google, you're not necessarily working for Google to make more ad revenue. You're working kind of against some of the other teams in some cases. I haven't worked at Google, so this is
Perspective.
my perspective. Yeah, at Huli rather. I think having like a team that's unified, that's all working on the same project, and that like Evan might build something that conflicts with what I just built, and now his thing is better, so we're gonna go with that instead. Like that's not a fight that I need to get into. I'm not gonna go and like try to politically destroy him because he has a project that's gonna kill my hard work. But like that all feeds into us building a better product, and I think that's something that you lose at big companies because you don't have the same like shared culture, shared vision. SpaceX obviously has one of the coolest shared visions, and I think that's something that you really need to maintain as you grow to keep the team aligned and to keep them from getting into this area in which they are not fighting together to build this really good product, but fighting each other to build a better piece of the product, or to have more ownership of the product, maybe not, to have more of a say in the product. Yeah.
Got it. And SpaceX, as you say, probably one of those rare instances of a big company that's still maintaining that, and you see how it's paying off for them, right?
Yeah,
like
just
absolutely incredible milestones.
Yeah, even at this day and age, they've been around for this long. They're still, it just seems like they're just like literally shooting for the stars, right? And they're just like doing these
Amazing.
crazy engineering feats that seem like that should be a startup idea, but no, they're still doing it, right? They have their Falcon that's just reliable and good, but yet they're still launching Starship, catching Starship. Like it's pretty incredible. Well, as we're wrapping up, I want to ask specifically for students who may be interested in learning more about your company, potentially joining your company, how should they reach out? What socials are you guys on? What platforms are you on? Where can people go to learn more about your company?
In general, we are pretty quiet. We technically do have a Twitter, and didn't you make us an Instagram too?
Don't look for that one.
Okay, we technically have a Twitter. I think if you send a message, we'll probably see it. Would not recommend that as a main form of reaching out to us. We do have an email, careers@navier.ai, and we have on our website, navier.ai, a careers button. It's pretty easy to find, top right, I think.
So your website is navier.ai.
Yeah.
That's the website. Got it.
Those are the easiest ways to get in touch with us. We are hiring, and we are also happy to chat with people who are interested in hearing more about this or who want some advice on starting a company.
Yeah, and feel free to reach out to either of us directly on LinkedIn as well. We casually peruse it, and we'll try to respond.
Cool. I just had one last question.
Go for it. You go for it.
What is the weirdest object you've seen put through a floor simulation? I don't know if you guys have seen some of the papers on Archive where people put a hamburger through and then
I've seen a cow.
The cow.
Yeah, I love the cow. Yeah, supersonic cows is my favorite.
Is that in your guys' training data set?
It's not.
I'm trying to think the weirdest thing.
One of our employees has a dog that has a lot of hair. She's just very fluffy. I really want to put her in a wind tunnel.
Wow. That would be some interesting data. So we did that fur moving around.
Yeah.
Some fluid structure interaction going on there.
Pretty tough to simulate.
It'd
I don't
be
think
extremely
she'd enjoy
difficult.
that.
Well, we'll be hoping to see a supersonic cow on your website sometime soon. Then.
Exactly.
Thanks so much, guys, for the time. Really appreciate it.
Yeah, it's been an absolute pleasure.
Great.